All right, so now what we're going to do is we are only going to use this solving our standard algorithm. So like I told you on the previous video, the picture is something that we just want you to be able to visualize and understand what is going on when we are actually dividing. So what we're going to do is we're going to go ahead and put this into our standard algorithm. So remember that we've got 78 hundredths divided by 3. So when you think about this, you can write it 78 hundredths, and I'm dividing it by 3. Because remember, here is the dividend. He lives in the den, and then you've got your divisor. So I can now go ahead and do this with my standard algorithm. So 3 goes into 0, of course, 0 times, and I'm just going to bring that decimal right on up. I'm not going to continue bringing the decimal down just because it's more work, it's extra things when you're doing your division. So just once you've moved it up, you can kind of almost essentially ignore it as long as you have it included in your answer. So 0 times 3 is 0. I'm going to subtract 0. I'm going to bring my 7 down. So 3 goes into 7 2 times. So 2 times 3 is 6. Okay. Then I have 7 minus 6 is 1. I'm going to bring my 8 down. 3 goes into 18 6 times. I'm going to subtract 18. If I went off the box, that is okay. So here is my answer to this problem. I can leave that 0 off. That is fine. You don't necessarily need to have it. I am going to tell you one thing, that if ever you make a mistake when you are dividing, if ever the number that you get after you have subtracted something is the equal to or greater than what you're dividing it by, then that means you can actually do it one more time. We will revisit this in Module 2 about what's going to happen if we accidentally do that, and it can go in one more time. Okay, so we're going to go ahead and do letter B. I'm going to set this up. I'm going to give myself enough room so I can write my answer, my quotient, right up here. I'm going to divide that by 4. So 7 and 28 hundredths divided by 4. 4 goes into 7. Well, it can only go in one time. So I'm going to subtract 4. I've got my 3. I'm going to bring my 2 down, but before I continue, I'm going to bring that decimal right on up. Okay, you just bring it straight up. 4 goes into 32. Well, I know that goes in 8 times. 8 times 4 is 32. 32 minus 32 is 0. I'm going to bring that 8 down again. 4 goes into 8 how many times? 4 goes into 8 how many times? 2. 2 times 4 is 8. I should have 0. So then my answer is 1 and 82 hundredths. I am going to tell you one thing on these problems. If you do have a remainder or anything left over after you've used all those numbers, you need to go back and check your work. Okay, so then I'm going to go ahead and do this last one of 17 and 45 hundredths. I'm dividing it by 5. So 5 can't go into 1. All right, I don't need to really worry about that 0 quite yet, just because I have not put that decimal straight up, and I can actually go ahead and put that there. If you wanted to, you could, but I know that 5 does go into 17, and 5 goes into 17 3 times. And the reason why I wouldn't necessarily put that 0 there is because when you're going to write this, you don't write 0 3. When I write that number 3, I don't write it that way. I write it without that 0. So that's why because I'm in like my 1s and my 10s, I'm just going to kind of have that invisible 0 there. So 3 times 5 is 15. 17 minus 15 is 2. I've already brought that decimal straight up, so I don't need to worry about it. So now I've got 24. 5 goes into 24 4 times. 4 times 5 is 20. So 24 minus 20 is going to give me 4. I'm going to bring that 5 down. 5 goes into 45 9 times. 9 times 5 is 45. So then your answer is 3 and 49 hundredths. Now, here's the deal. Some people are going to say, oh, well, I know that it goes in 45 and I'm not going to put this part right here. You do need to do that to check to make sure that you have done everything correctly and do not have anything left over. So now we're going to do some word problems, and it says Grayson wrote 1 and 47 hundredths divided by 7 equals 2 and 1/10 in her math journal. We're going to use words, numbers, or pictures to explain why Grayson's thinking is incorrect, because that is incorrect. I'm going to just go ahead and let's do our standard algorithm because we know how to do this, and kind of to save time not to do our pictures and drawing and everything else. So I'm going to go ahead and do what I already know. So 7 goes into 1. Nope, it does not go into 1 anytime at all. So I'm going to go ahead and put that 0. 0 times 7 is 0. 1 minus 0 is 1, and I'm going to bring down that 4. Okay, 7 goes into 14 how many times? It goes in 2. I'm running out of space. Goes in 14. 14 minus 14 is 0. Bring down my 7. 7 goes into 7 one time. I'm going to subtract that 7, and I'm going to get 0. Ran out of space. Sorry, guys. So here is what her answer should have been. Okay, so her thinking, yes, her numbers are correct, but her decimal is in the wrong place. And probably what she thought is because possibly, well, the decimal is, 1 over from the 1, so that's how I'm going to do this. So this is why it is very important that when you are dividing, you just bring that decimal straight up. She must have just went ahead and done something different. I'm not sure what she would have done, but she has to make sure that I can't divide that 1 into 7 different parts. It won't go in at all. So that's kind of why she was thinking wrong with that. And if you would like to pause this, you can go ahead and write your thinking out here. Number 4, it says Mrs. Wynn used 1 4800 meters of netting to make 4 identical mini hockey goals. How much netting did she use per goal? So we're going to take this and we're going to turn this into a division problem. So I want to take this 1 4800. I want to divide that into 4 different parts. So I'm just going to, because I would rather use that standard algorithm, I'm going to create the standard algorithm to figure out how many meters she uses. So what I already know, 4 cannot go into 1. So I'm going to have to put the 0. I'm going to already bring that decimal up because I know that that is what comes after that 1. So 0 times 4 is 0. I'm going to bring my 1. I'm going to put my 0. 1 minus 0 is 1. I'm going to bring down my 4. So now I can go ahead and do 4 minus 14. Well, that can go in 3 times because 3 times 4 is 12. Okay, so 14 minus 12 is going to give me 2. I'm going to bring down my 8. 4 can go into 28 7 times. Subtract 28 because 4 times 7 is 28. And I do not have anything left over, so it checks off. So each goal used 37 hundredths of a meter of netting. Okay. So now we're going to go ahead and move on to number 5. It says Esperanza usually buys avocados for 94 cents. I know it's hard to see, 94 cents a piece. During the sale, she gets 5 avocados for $4.10. How much money did she save per avocado? So this is saying it wants me to use a tape diagram. So I'll go ahead and show you guys this tape diagram. Okay. So basically, she gets 5 avocados. 1, 2, 3, 4, and 5. So here's avocado 1, 2, 3, 4, 5. Okay. I know that she only spends $4.10. So I want to take this $4.10 and divide it into 5. Now, I can't very easily divide 4 and 1/10 or $4.10 nice in my head. So what I'm going to go ahead and do is I'm going to make an algorithm. So $4.10, I'm going to divide that by 5 because that's how many avocados she had. So 5 can go into 4. No, it can't. Bring down that 1, but I'm going to put that decimal before I move on. So 5 can go into 41. Well, yeah, it can. So 5 goes into 41 8 times. 5 times 8 is 40. I'm going to do my subtraction. 41 minus 40 is going to give me 1. I'm going to bring down that 0. So 5 goes into 10 2 times. 2 times 5 is 10. 0. So she actually spends 82 cents on each avocado. That if I were to go through and I could multiply 82 times 5, or I could do 82 and add it 5 different times, that is how much money That is how much money did she save per avocado. So that is how much money each avocado costs. So now what I want to do is I want to figure out how much money did she save. So if I know that the avocado originally she would pay 94 cents, sorry guys, and she only has to pay 82 cents for an avocado, well, let's see how much money does she save on each avocado. 4 minus 2 is 2. 9 minus 8 is 1. I'm going to bring that decimal down. So she saves 12 cents per avocado. Okay. Go ahead and go to the next slide to find out what problems you need to do.